Hello everyone, I'm Kian Carreon, a BS Chem major from UP Dalaman, and welcome to Project Agbayan's first video in the Prelab Notebook, where we try to help students to understand the fundamentals of different lab techniques. The technique that we will be demonstrating in this video is the weighing of reagents and samples. In the lab, weighing is done with the help of the analytical scale, which measures the mass of an object. However, in the field of chemistry where errors are avoided, the analytical scale is made to be extremely accurate and thus very sensitive to any forces on the balance pad. This makes it prone to errors if left vulnerable to the environment. That is why it has this compartment called the weighing chamber to make sure that only the object of interest is being measured. Now that you guys are familiar with the instrument, let us now go to the weighing techniques that make use of it. There are two weighing techniques that can be used depending on what is needed in the experiment. The first method is weighing by addition, where the mass of the reagent is determined by finding the amount of mass added to a container once the reagent has been placed in it. This is done with non-quantitative chemistry, where deviations in variables such as concentration do not result in significant error in the findings. The second technique is weighing by difference, which finds the mass of the reagent by taking the difference in the mass of its original container before and after an amount has been taken from it. Weighing by difference is done when absolute accuracy in measuring is needed for producing solutions of specific concentrations. This is because weighing by difference actually eliminates errors that may come from using tare or from the zeroing of certain containers on the scale. To better understand when to use these techniques, we will have an example of preparing a 100 ml stock solution of 1 molar concentration from AR grade sodium chloride. Since we are making a stock solution of a certain concentration, it is best to use weighing by difference to prevent deviations from this value. Now, to know how many grams of sodium chloride is needed, we first compute it using the given volume and concentration of the stock solution as well as the molar mass of the compound. The molar concentration of 1, which means that there is 1 mole of sodium chloride per liter, is multiplied to 100 ml to find that we have 0.1 moles. We then multiply this to the molar mass of sodium chloride, which is 58.44 grams, to get the value of 5.844 grams, which is the amount of sodium chloride that we need to weigh. Here are some important reminders when weighing. If you happen to take too much of a reagent, do not return it to its original container, as it has already been exposed to the environment and the instruments used in collecting it, making it contaminated. In the same way, always close the container of the reagent when not in use, to prevent it from being exposed to the environment and to ensure that it does not become contaminated with impurities. Second, take your time when trying to weigh a reagent. Do so by adding small amounts at a time to avoid exceeding what is needed and wasting the excess reagent. And that ends our presentation of the techniques and instruments used in weighing. Hopefully you guys have become more familiar with these techniques and you've gained a better understanding of how and why we use them. In our next video, we'll be putting that knowledge to the test as ACE shows you how to turn solid samples into a solution of known concentration through weighing and pipetting techniques.